All right. Now we're going to start our discussion on templates. Do we have time? Okay. So templates we'll be using pretty much for the rest of the entire class. From this lab onwards, your project will not, well, projects will probably be the only time you don't necessarily have to use templates, although you probably will be because you'll be using the standard template library, which by the way has the word template in case you didn't catch that. No, I didn't think so. All right. Single body of code for related functions. All right. That's syntax. Let's see, did they give you a nice, beautiful example? They sure don't. All right. Let's go over and have an example. Do main.cpp. Include iostream int main int argc char argv. All right. And let me make sure I type that correctly. Looking good, and it runs. Perfect. Okay. So when you want to, I don't know why I did that. So when you want to use a template, you start with the keyword template, and then you say what type of class you want to template it on. So we'll do class T. T can stand for type. All right. We'll have my function return T. We'll call it sum, passing in, we'll say a TA and a TB. And we'll have the whole code return A plus B. Okay, so if I were down here and I did int A equals 5, B equals 10, and then I did sum of A comma B. Actually, let's print that out. And let me go ahead and make this a little easier to read. Okay. Intuitively, what should this do? Well, intuitively, I mean, what do you think this is going to do?
Add them together.
Add them together.
And return the sum. I think it's going to be
And return the sum. Yep, 15. Okay. All right, how about now? Is it still going, is this going to work?
Yep.
Why is this going to work, Jonah?
Because T is just a template for
Right.
whatever you
So right, the template. So I declared what the function is, and then depending on how I use the function, if I passed in integers or doubles, it would then generate another function for this code. Now, could we have done this a different way? For example, could we have done this a different way? Yes, that was rhetorical, because obviously we could do int sum int A comma int B, return A plus B, and then we could have also done double sum double A double B, return A plus B, and this will also run, but it's the same thing. It's very important. What's that?
It's more coding.
It is more coding.
You just do the template.
Just do the template. All right. Very important. What I did just now is exactly what the compiler does. It sees your template, says, okay, I got a template. The first time you say, hey, look, I'm going to call the template function, passing in two integers, it generates that function. So, just to be clear, when it reads in this code, says, all right, I have a template, it does not create any code for you yet. It has not done anything yet. It just says, all right, I have this template, I'm holding on to it. When it comes down here, it says, okay, look, you are calling sum of A and B are integers, because I know that because you declared them right here. Then it generates this piece of code at that moment in time and sticks it up there. Then you have doubles. Once it sees sum C comma D, it goes, okay, Now I'm having sum, but now being passed two doubles. It's not the previous integer one, it's a double function, so now it generates this piece of code as well. All right, any questions? Nope. All right. Let me go ahead and get rid of this. I'm going to go ahead and delete the extra code so we can stick with the templates. Now for a good trick question. Maybe not a trick. Can I do this?
Yes.
We have a bunch of yeses. All right. We have one no. Nope.
That's two different.
So we convert the int to a double.
That's not the reason why it didn't work.
Different types.
It's two different types, but I've only templated on one type. So I'd have to
convert the int to a double.
Can you convert it into you can?
Well, I'm saying like it wouldn't automatically do it for you.
No. No, I mean, so what you're thinking is if I did this, then yes, it works. Because I converted the integer to a double, and the compiler went, oh wait, I have that function.
Can you change something in the template to also make it work too?
You could template on two different types. So we have T, we could have, be like the Terminator, T2.
Ooh.
Oh, it didn't like that.
Because it still only had, because the sum doesn't know what to do because it's only T, right?
Yeah, hold on. What's going on here? Has not been declared. Oops. Class. Got to put class in front of each one of them. There, now it worked. Oh. But what's tricky here is what did it return? It actually returned an integer because the first parameter being an integer matched that t and therefore returned that t right here. Just a little side comment. So I'm going to go back to the other version because I believe it's cleaner. And did I forget to? Oh, I forgot my parentheses. Boom. All right. We're good so far with the functions. So the functions, this probably makes a lot of sense for. You want to do a bunch of sums of integers, doubles, floats. Could T be a class? Could be our student class. What would we have to overload for it to be our student class? What operator would we have to overload, I guess, is the first way. Because if I've created a student class, can you do student plus student? Not unless we overload the plus operator. Then it would work just fine.
Wait, so you'd be adding two students together? Or would you?
Yes. Remember, it's just generating the code. It's not trying to do anything, any extra work. It's just a code generation tool. This is different than how Java did it. But I ever talked about how Java implemented generics, which it does everything on runtime. So it figures it out later, but this is doing it at compile time because it's copying, pasting code for you, is essentially what it's doing. Okay. Any questions so far? All right. All right, so class, I think we got that. Function declaration, we got that. Class templates. So, you can template functions. You can also template classes. Let's see. Okay. What would be a great example to template a class on? That you've seen from your labs. Array. Because then it doesn't have to be an integer array. It can just be a generic array. So let's go ahead and at least start that. So we could have template class T. Now I'm just using T. It could be K, V, or just some long term if you want to. I'm using T. There's different conventions here. Some people use T, some people use E for element. I prefer T for type. But it could be anything you want it to be, as long as it's not another reserved word. Class array. And private, let's see, what would it need to be?
Size.
Yeah, so we have int m size as well as, what was that? M array, the M array, aka T M array. Do you see what I'm doing there? M array is going to be a pointer to T, whatever T is. Public. So we're going to have array. We can be passed in a T array as well as a size. All right.
So when is T like? So on the bottom, when you tried to do A and D, it didn't work because they were different types.
Correct.
So when is T kind of set to a certain type in terms of like?
The compiler tries to figure it out. It's not exactly complicated, but I mean, it's not simple is what I meant to say. It is complicated, but the compiler is going to try to figure it out. Now, with sum, that would be easy because it's sum, and then you're being passed two parameters. It goes, looks in its table, identification table, and say, all right, what could sum possibly mean that we have defined it? Well, we haven't defined a variable named sum. Oh wait, we have a function named sum. Uh-oh, wait, it's a template that takes two parameters that are the same type. So first type is integer. Okay, well I certainly hope the second type is integer. Oh, it is. All right, let's go ahead and generate a function. It's kind of a complicated analysis, but
So are templates like good for performance?
yes and no.
I just feel like you'd have to jump around a lot trying to figure out what you mean by yours.
Yes, but at what time is it figuring it out? Is it doing it during compilation or during runtime?
Yeah, so it's
Compile time. So once you compile your program, you've already paid for the performance.
Okay, I see.
That's different in Java because Java tries to figure it out during runtime. So you're paying the performance every time you run the program. But there's another catch. In Java, just to make this even more complicated, Java doesn't generate a new piece of code necessarily if it doesn't have to, because it's actually using a table to index into where to jump to because it's a type of bytecode. So it's really, in Java, in general, it is just one function. In C++, it's different functions. So that means in C++, your code is going to increase in size, while in Java, it's going to stay more compact. But the problem is Java's jumping around a lot more than C++. So C++ could be faster because you're jumping around less. You actually have the code, you're compiling and optimizing it. Java might be better because since the code is shorter, it's going to fit better in your memory. That is, the performance of that is actually something we'll talk more about in architecture, but is fortunately beyond the scope of this course. But that is an awesome, great question. Great question. Okay. Let's see if this compiles. Just make sure we typed it correctly. Nope. Before array. Let's see, class array. Oh, I meant to type that.
Okay. That was always for Java, right?
Yes. We kept talking about Java. When that happens, just make everything a pointer. Stop using brackets. It's don't use brackets unless that's the way to do it. Yeah, because the brackets go at the end. All right. Okay. So let me create a function. Let's say let's see, template function test. And the reason for that is simply so I can copy and paste all this code down here and not mess up main for now. Perfect. Let me go ahead and compile that just to make sure when I commit it, it does actually work, and it does. Perfect. Okay. I'm going to move this up to the top so we're not looking at it anymore and we're just focusing on this array. Beautiful. Okay. So if we want to create, let's see, arrow y, what values do we want? 5. Any others?
72.
That's weird.
Thinking about that too.
Are you serious? Yeah.
I just threw out a random number.
Anything else, guys? All right, 12. We're done. All right. When you template, or when you use a template of a class, you actually specify the type. Beforehand, the compiler would try and figure it out, but now we're actually going to specify it by putting in less than int, so it's an array templated on an integer, and we'll call it ARY1, passing in ARY and the value. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. Okay, is this going to run?
I hope so.
Undefined reference, blah, blah, blah. Undefined reference means, what does that mean?
Undefined.
It's undefined. What's not defined?
The actual rate is not valid. Wait, no, wait.
Do you have?
I don't know.
Yes.
What's the ARY1?
Oh, that's just a variable.
Oh, okay.
We can do it this way. Device under test, if that helps any. Same problem.
What was it saying?
Undefined reference, that's a good question. Undefined reference to ARY sub int, here, array, integer pointer int. Undefined reference means that function didn't get compiled in. Why did that function not get compiled in?
Said needed a pointer. Right.
It needs a pointer. Well, we have a pointer, right?
Okay.
Look at the constructor. Got a
Yeah.
pointer to a t. Yeah, so we got that and the size. That heading looks pretty good. What did we not do?
Do you have to create? That array is created on the stack, isn't it? Is that-
Correct. It's on the
Okay.
stack, not the heap. Sorry,
So-
I'm not using new.
Like, don't we want an array pointer?
It's on the stack, so we don't need a pointer. Good question.
I was looking at the template. I tried.
Ooh. We're all stumped.
Well, you're not. We are.
Yeah, well, sure. Okay, fine.
Drop the act. We know what's wrong. Yeah, we know that you know what's wrong.
So this code's not compiling. Well, it compiles. Actually, it compiled. No, it doesn't compile. I lied. It doesn't compile. We get an undefined reference to array sub of temp, of an integer, constructor array being passed in an integer pointer and an int. We've already templated the class. We have the constructor array. The array is a pointer to something of type t, which we declared here to be an integer, and then we're passing in size. So that function's been declared. What's the problem?
Oh, it's out of scope, right?
No, it's in scope. It's public. pointers are fine. C++ is going to do this to you all the time.
array?
No? Well, kind of.
Because you're not using it,
Yeah.
are you?
Well, have I used MRA?
No.
So, well, what's the problem? What's the actual problem here?
Undefined reference.
Undefined reference, which means the code for the constructor function was not compiled in. Why is that?
Never gave array value.
It's true, I never gave MRA a value. That's a logic error, but that's not a compile time error. We're having a compile time error right now. But you're on the right track.
Interesting stuff.
Where's the code for the array constructor?
Is it?
In class. Oh, we
Is
gotta
it-
call array, what's the thing, the double colon, right?
Okay, we could do it that way. You're on the right track.
Is it because you're trying to pass in the array directly and you're not using a pointer?
No, that's no, ARY is a pointer.
Oh, okay.
That's a pointer. That's another way of doing pointers. This is how you have to do it if you're doing it statically. Well, the way you should.
Okay.
Should we be saying like array
The whole-
DUT equals new array?
No, we're just creating this array on the stack. We could create it on the heap if you wanted to, but we're going to get the same error. We'll go ahead and create it on the heap.
Is it okay? Because I think the parameters say that it's a pointer to an array. We passed in an array. Does that work?
ARY is a pointer. Technically, this means the pointer's on the stack, so that's why this is okay, because these are created on the stack, and then it's going to be automatically dereferenced, so you don't have to worry about it. So this is actually fine, but we're getting the same error.
Is it
Oh,
because it's not
can I
of the
convert?
array- It's not of the array class?
Hold on a second. Got the new. It's not of the array. No, that's fine. Undefined reference. So I'll do it again.
It's not.
Let me ask the question again. Where is the code for the array constructor?
It's in the template class. Well, it's in class array.
Wait, what? Where? No.
Oh. Is it because you have int array?
Okay. All right, let me answer this for you. There is no code. We have not written the code for the array constructor,
Oh.
right? That's a semicolon. So that's a function declaration. It's not the function implementation. Okay, it works now.
What?
Yeah.
Did you do that on purpose, or was that an accident? And you just like you saw, you're like, I see. Just missing something. slightly.
No, that was done on purpose.
Oh, okay.
Because I wanted to. You got to really think about what's going on and reading the code specifically. You have to really be detail oriented here, guys. Undefined reference means it wasn't able to grab the code. Why wasn't it able to grab the code? Because we never wrote it. There was no
That was a
code.
trick question.
It wasn't a trick question. The
Yes.
compiler told you exactly what the problem
Milo
was.
was wrong.
Yeah. 90% of the time.
I think your pilot's always wrong.
Yes, PJ?
Whoever
Why do
wrote
we
it.
use the int in the brackets like that beside array?
Okay, so you stepped out.
Yeah, sorry. I can
Array
remember.
is a templated class, and when you use a templated class, you have to explicitly declare what the templated types are.
Gotcha.
So you do that by putting the brackets in int, so I'm saying the first one, aka class T, is now going to be an int.
Oh, gotcha.
All right. We're going to put this back on the stack, because it kind of makes our lives a little easier. Let's see if we're still good. Yeah, we're good. Okay. Well, that was fun.
Yeah.
It only took like 15.
All right. Now I'm going to start talking about header files here. So I'm going to tab new. We're going to call it array.hpp. If not defined, array underscore HPP. Copy and paste it, and then we'll define it. And then we'll end if. Did I ever tell you why we do this?
Yes.
Good. This just makes sure that if you ever include this header file, you only include it once. Because if you have not defined array.hpp, aka you haven't included the header file, define this variable, then go and do whatever. And then it's then as long as you make sure you put your code between these two, the define and the end if, we're good to go. So I'm going to take this, I'm going to go over here, paste it, and inside of main, we're going to go up top and we're going to include, let's see, array.hpp. I don't know why I didn't put that in quotes, but there we go. All right.
What is the shortcut for switching between tabs like that?
GT.
So you have to hit like.
All right. So let's see if that compiles. It does. We're still good. All right. Now we have a separate header file, but we want to use a separate CPP file. Make sure our code stays modular. Now I'm going, obviously for this example, it's a little, I want toots to do that, but I'm just trying to make sure you understand how this is set up. So if we want to create an array.cpp file, we tab new array.cpp, and then we want to do the constructor, so let's copy and, well, let's change this back into a semicolon, which gave us the original error because we hadn't declared what the function is, but that's because we want to declare it in the CPP file. All right. How do we declare the templated function of a class in the CPP file? Well, first off, at the beginning, you always put in template on class, lowercase class t, and then you have the class name subscript t, colon, array, and the rest of it. All right, so that's the actual code. There's the HPP file. There's main. If we try and compile it, undefined reference. So what does that mean?
It couldn't reach the array.
That's because we never actually included array.cpp in our compilation. All right. This is where things are going to get weird. Array does not name a type. All right, didn't get, not weird yet. Inside of the CPP file, I never included array.hpp, so let's go ahead and include that. Now things are going to get weird. All right, now things are weird.
Oh god. Not again.
Okay, I'm going to explain this. It's going to make no sense to you. And then I'm going to tell you how to fix it. And then you're just going to nod your head and do that from now on.
Okay.
All right. I understand that.
If I get hundreds, deal.
But here's the explanation. This normally should have worked. On any function that is, or class that is not templated, this would have worked just fine. The reason this did not work is because when the compiler goes to compile array.cpp, it is compiling only this file and nothing else. When it looks at a template, and then it has a template, but it never sees any code that uses the template, it does not generate any code. So no code is being generated when you compile array.cpp. Nothing is coming out because it's all templated. Because templates are literally a template. It is a blueprint. It's not actual code. So when the compiler looks at the CPP file, it does not actually generate any code. That's why when you jump over here and you compile array.cpp and main.cpp, it's not generating any code because it was never used. All right? So now we have this chicken and the egg problem. Yeah, which came first? Because we're over here in main.cpp. We've included array.hpp, which declares what the function is supposed to look like, or the array templated class is supposed to look like. And that's why when we use it, it compiles okay under main.cpp, but when you try and link it together, you get an error because it doesn't actually have the code for an array templated on int. There are many different ways to do this. You could technically force the template creation side of CPP, which I do not recommend doing. The other thing to do, which is very bad, never do this except when using templates, is you're going to, inside my header file, I'm going to include array.cpp. Okay? So what this does is when you include the header file, you're now including the templated code as well. That way when main tries to use the code, it's going to see the implementation and be able to generate the code as well. Okay? All right. So now we get rid of array.cpp, we compile it, and it works, or it compiles and runs. So, in other words, if you are doing it for this class, when you are using a templated class, include the CPP afterwards inside of the header. That is the solution.
If we're doing this with like a makefile, and like we have like the array.cpp like in there to compile, do you just want us to get rid of it?
It doesn't matter.
It doesn't?
Yeah, watch this. Notice in here I didn't include array.cpp. I'll put it in. Oh, wow. Previous declared. It does matter. Wow. It shouldn't have. Oh, what happened here? So we did a redefinition. That should not have worked. That should not have given that problem. Include inside of the header file. Oops. Oh, get rid of the include up there. There. Nope. Still have that problem. One moment. I have forgotten how this was solved. But I did it for your lab. At least I hope I did. All right. Oh, that's evil. Okay. All right. If define array underscore HPP, then you actually put in the code, and then you end if. There. Now it's happy. Either way, it's happy. So, what's happening here is if the array header file has been declared, aka you're including from the header file, then you go ahead and implement the code, or you write the code out. Otherwise, ignore it completely. That way your makefile will not have any issues, and if you decide to compile this separately for whatever reason, it'll just ignore you.
Okay. That would really suck if you thought you were doing everything right. It was just ignoring you the whole time.
I have not found a better solution with templates. If you see one, please tell me. I have not looked at the latest revisions to C++. They have done a ton of revisions recently. Hopefully they have addressed this problem. I have not been able to check a while because they've been jumping around a lot. But this is a well-known issue because the solution is not clean. Or at least the solutions I've seen have not been clean. All right. Well, you have an example in the class code, and I'm actually going to provide you an example for the lab as well, so we should be okay. All right. Any questions?
Not yet.
Not. Love that. All right, let's jump back to the slides. See if I missed anything. Header files, we just talked about why those. Wow, that was really short. Okay. Summary, operator overloading. How many people here love operator overloading? Just Matt, good job. It's okay, it's good. Can provide some concise notation for user-defined data types, but it can also mess you up because now you don't necessarily know what those operators do. Friends are bad. All right. Classes with pointers must overload. Oh wow, this is a summary of all the slides. All right, templates. We talked about function templates and class templates as well. We are parameterizing the types. That should be somewhat useful. Notice it's called the standard template library because it's going to have something called vector, which is really just the array class that we've been writing so far, but they've already implemented for you. Do not use vector for the labs because you will not get a good grade, namely a 0 if I see that. But moving on, once we finish these labs, I'll let you start using vector for the future classes, and I'll start talking about the standard template library, because in reality the point of writing these data structures yourself is to learn them, and then once you learn them, why they behave certain ways, please just use the library code. Their code is more correct because they've tested it, and it's a higher performance because they've obviously optimized it. All right, any questions on this before we talk about your next lab? Yeah, that's right.
Are you assigning another lab Wednesday?
Yeah.
One or two?
Hopefully just one.
Yeah,
hopefully. I plan to only assign one.
3 labs.
Hey, look, we lost some time.
Yeah.
And your project. Don't forget your project.
I included.
Oh, yeah.
Labs.
I know.
Okay.